So we left off right here where we were talking about how this poor student, because he only had one low test, his average goes a lot lower than the median right here, right? So the average mean, if you will, okay? And that leads us to the idea of resistancy, namely that the median, with a low outlier like this, the median's a better choice because the median resists his low score of 24, but the mean does not, right? The mean gets kind of pulled all around based on when you have high and low scores. For example, and that's the important point number one, the arithmetic mean is extremely sensitive to very large and very small data values. So you get, in other words, outliers. That's what those are called when you have really small and really large outliers. The median is not. So we say the median is resistant to extreme values, but the arithmetic mean is not. So let's just think about, for our class, the average salary. And I'm just going to grab a picture, something basic. Hold on. Something really skewed. This will work. Okay, so pretend this is the salaries in a class, in our statistics class, right? So here we all are, and then way out here, honestly, way past out in the white part of the screen is Bill Gates. Like, he walks into our class and he's part of it, okay? Well, what that means is that the mean is going to get yanked towards him, but the median isn't, right? So let me grab a picture here. Okay. Coming back. Hold on. Okay, so here's the picture. So because Bill Gates is way out there and all the rest of us are over here, it would make our mean, like, pretend, like $1 million a year. But our median would be, I don't know, I'll just make it up. How about 25,000 a year? Okay. So in other words, Bill Gates causes the mean to get pulled higher, but he doesn't affect the median. The median resists his high salary. Okay? And it kind of happened with our, even with our, hold on, I gotta go back. These guys, the number of pets, because we had one student who had so many pets because they lived on a farm, it caused the average, the mean, to be 2.08, but the median was only 1, right? Well, it's getting yanked that much higher because of this person right here. So if that person wasn't in the class, then they wouldn't have had that effect. Okay? So that's the first point. The arithmetic mean is not resistant, but the median is. Okay? And if that's the case, then we also have this. So when data sets have unusually large or small values to the entire data set, then the distribution is skewed, right? We ran into that in chapter 2. Like this, for example, skewed right. And the median is the preferred measure. Once it's skewed like this, you don't want to look at mean, you want to look at median. So I brought up math exams in college because math exams in college usually have, let me find it. Hold on. This kind of shape, right? Skewed left. Why? Well, because you're limited on the high end with how high you can go, right? So if you're limited, you're going to have most people, in the 70s, 80s, 90s, but you're going to have a couple people really, really low, and that's going to cause the data to get skewed right like that. And if that's the case, you should be asking for the median is a better measure of center than the mean because the data is skewed. All right, now you see this all the time. You don't even realize it. Median, not media. Okay, let me go find an article and I'll be right back. So for example, here's one. This is a demographic website where it talks about, and I looked up 49201, the zip code where JCC is at, and see right here, median household income, right? Why are they doing that? Well, because that's the appropriate measure, because in Jackson, just like any place else, there's a small group of the population that makes over $200,000 a year, for example. But most people are down here, right, in these groups. And it's not fair to use mean because the mean will get skewed to the right, right? So we use median instead.